So, last time I sent you a message, actually, last night. Last time there was some discrepancy. Let's start with it. We estimated the Planck constant and we got a bad number. And it was suspicious that the numbers are not good. So in the meantime, I checked what happened. You know, I have some material from Szilárd Szabolcs and from other person in Hungary, in PDF form, portable document. So I'm not masochist, so I asked the ChatGPT to make the LaTeX slide from them. And then I improve it because, for example, it cannot get the pictures or the pictures are not good in them. So I processed one exercise, leaflet or I don't know, some practice material, and the ChatGPT misidentified one number. 17 was identified as 9. So that's why we had a bad Planck constant last time. You will understand this because the original good exercise will be your homework, one of your homework. I can give you the second homework. It's coming soon. Actually, I wanted to give you today, but I don't know to future. It's quite horrible that I don't have internet on the train. And check exercise. Exercise 6, because I finished it after you left. Actually, some guys came and they were from the secondary school and so frightened what I had done. Okay, I received free homework of you. Thank you very much. But I would like to tell you something important. Draw picture. It is good for you. You understand better the exercise if you have a picture. Have you ever had a Galilei imagination or experience? Have you looked at a telescope, an astronomical telescope? Any of you? No? No? I'm also an amateur astronomer. I was an amateur astronomer because I became a professional. And there is a good way improve your visibility. You look in the telescope and draw. You look at the moon, there's a crater, a mountain, and then draw. You look to the Mars or the Jupiter, you see the belts of the Jupiter, and you draw. Why? Because there is a turbulence in the atmosphere, and the image that you see is sometimes worse, sometimes better. Your brain put them together. If you draw it, you got a better visibility than just look in them. So the image that you draw is better than that you see because your brain works in this way. This is not so difficult here. Just draw, understand the exercise. Not the formulas are important. The process that we experience, that we try to understand, that's important. Not that important what is the number of the particles, the electrons at a certain level using the Fermi Dirac structure. The important is understanding there is a piezoelectric effect, there are volta batteries, there are photocells, there are conductivity, and then you understand how your tools are working, how the transistors, the N and are working, how the GPS are working. At least you have a clue, and if there is a problem, then you can fix it. If you have to improve it, you can improve it. You actually, it's not expected you in BS level to do science or research or anything or develop, but perhaps you don't want to live as a slave or a well-trained monkey in your job. So that's why I explain you physics, because you both better and you need more information to be a better professional. Okay? Here, I start this exercise, and I think it's better if I open the original image. It's here. I start with the exercise. What was it? Some photon hits the metal, kick out electron with some wavelength and another wavelength, and these numbers are different. So I just write down here the Planck constant and the frequency. This is the energy, and this energy becomes kinetic energy and some energy that's necessary to leave the metal. I fix the two equations. These are linear equations, and there was one extra information that the second photon's wavelength is double of the first one. It means its energy is also half of them. So we finished the exercise here. So I used the calculation and everything, and I got the wavelength, and then I determined this energy that is necessary to leave the metal. You can check my beautiful handwritings and got the result. I uploaded this to the Moodle and to the GitHub. Yeah, I recognize something. My third job is at insurance company. Show you something which is funny. So, can you see this? It's a Moodle. This is the Moodle. That's funny. You don't need to learn insurances, but this is made by Moodle. So my Moodle is not in that level, but it's possible to do this. Text and selection and everything. Actually, I participated one job once at Milton to do something similar. So this is Moodle. It has not some. It's not so important. I just showed you. So we are here, and now practice. No, where we are. Okay, so we are here. Great. This. Well, that will be challenging. So there is a spaceship. Its length is 100 meters, and it passes before Mr. Observer. Within 4 milliseconds. The question, what is its velocity? Okay, let's start, and I'm pretty sure we will get a wrong result first. Okay, so V is L per T, 100 meter. So what we got, that's meter per seconds, that's fine. And this is 25 times actually this seems to be right. No. I made a mistake and you didn't tell me. Two mistakes. This is 8 because this. Oh no, sorry. Wait. So this is. Oh, that was good. Okay. So this is 25. This is 6. And this is 7. So this seems to be good, but why? And why I have doubt whether it's good or not. What is the speed of the light? approach the speed of the light, then the time changes, also the length of the spacecraft changes. But this is something less than 1/10 C. So I can use this. With higher velocity, I could have a problem. Okay. Aha, great. Do you know what is a meson? Do you know what is cosmic radiation? Cosmic radiation is high energy radiation from the Earth. The main source is the Sun. The highest energy came between the interstellar and from the intergalactic space. These particles are coming, collide with the particles, the atoms of the atmosphere, and creates so-called mesons. The meson is a particle. Its charge is 1 like the electrons that you know very well, but the mass, its mass, the mass, is 200 times higher. They are unstable and they survive 0.2 seconds. It is not enough to reach the surface of the Earth from the higher atmosphere, but they reach it. Why? Because their speed is so high that the time is flows much slower. So they still exist when they hit the detector of the Earth. We have a very similar task here. We have electron in a radioactive particle beam. You know radioactivity? If not, next time you will know what is it. Radioactivity is breaking the core, the nucleus of the atoms, and some particles are coming from it. For example, protons, sometimes neutrons. Neutron is not the normal radioactivity, but protons, helium nucleus would come. Here, electron comes. I talked about positrons also. Positron also will come. The lifetime here is 20 nanoseconds. And if you have a reference frame, I don't know how they did it, but in that reference frame, they survive only 7.9 nanoseconds. So the question, what is the velocity of the particles? particle travels with v velocity, and then decays. There are new particles, actually the reference is quite stable, so this is a bit BS, but doesn't matter. BS doesn't mean motion. But doesn't matter, so it exists. It should be exist 7.5 times nanoseconds, but it exists 20 nanoseconds. The only explanation is that the time is goes slower in that reference frame. Actually, it's not good. The time, so the observer, which is in the reference frame of the particle, thinks the time flows normally. But we, Mr. Observer, we experience that the time is slower. So what can we do? First, we check the formulas. And where we are. So this was type. Now it's quantum. Here, right. Oh, you cannot see. Can you see? There. Here, time dilatation. In this reference frame, the time is flowing slower than we know this. We know this, we know this, we don't know the velocity. So what we have? so we have to solve this. Well, not necessary. So this is Oha. So if I calculate it well, then this is something what I had done. I just calculated what's this. This is something I'll do it again. I don't know whether I made a mistake or not. Okay, it's the same. So, I didn't write the result in meter per second rule because this is better. 0.93 C. It's 7% less than the light speed. It's quick, it's large. Light speed. So that's why the particle survives. Okay, so it was not a few minutes ago. Do you remember the time dilatation? That twin paradox. If you, it's special relativity theory, if you are traveling faster, not faster, but very fast, and you approaches the speed of light, then the time starts to slow down for a reference frame that is outside of your reference frame. Also, your size and the direction of your speed is become thinner. We don't lose weight actually, but your weight, not weight, your mass also increases. This is the effects of the special relativity theory. What you should know, they exist, and then check the formula. So the task was the following. There is here a particle. This particle should die a long time ago. It exists 7.5 nanoseconds. But the observers see 20 nanoseconds. So the only reason could be that it goes fast, very fast, so the time slows down for the observer outside of that reference. We have a formula. If you have speed v, you have the speed of light in vacuum, of course. Then you can calculate the time dilation. So this is the time how it flows in the moving reference frame, and this is in your reference frame. So this was the basic formula, and this was the knowledge. And now, please listen. Not this is important, because this is only math. The important was to understand what is the problem. And when you understand what is the problem, you understand the problem from here, from the drawing, if you can draw. Usually, somehow you can imagine the things. And then you can realize you can use this formula. This formula is not important, it just makes our work faster. The important what is behind it. When I explain how the time slows down, what is time dilatation. You have this formula, you understand the problem, you know the formula, you know the theory, then you can do the calculation. This is only math. And you got the results. Which is expected. Why expected? Because at the beginning, I told you why that particle survives so long. Because of time dilatation. So I expect a high velocity for the particle. Otherwise it's not possible. So the physics, not this calculation, not this formula, this image, that's important. And not only here, in your real life, try to understand what is the problem. Any problem. It could be social problem, it could be mathematical problem, chemical problem, in the office. Just understand you should have a model. That's physics, that's physical or engineering thinking. That's the essence, that's why you learn physics. Okay. Class is dismissed. Thank you very much. We will continue next time. I will do your homework. Have a nice holiday. Thank you very much.